Hello and welcome back to Side High Tech. In this video, I'm going to show you to make an Amazon Prime box cutout Jitter dog with using an Attiny85 microcontroller. Let's get started. As you can see right here, there are these little designs that are on these flaps of this Amazon box. And I'm going to go ahead and cut this out and electrify it. And these are the items that you're going to need to make for this project. The items you're going to need is this cardboard cutout of this little dog that came from this Amazon box. You're also going to need two 3-volt button cell batteries plus two 3-volt button cell battery holders, a vibrating DC motor, two push-button lock switches, an RGB LED common cathode, an 8-pin IC socket holder, and of course, an Attiny85 microcontroller, which will control the RGB LED. Now, let's go ahead and assemble this project, and let's get started. First, I'm going to start with cutting out this dog with the scissors. And we'll just cut it out like that. There we go. Next, I'm going to take a X-Acto knife, so that way I can cut out the fine details. Now you have these pieces all cut out. Done. Next, I'm going to attach these legs to the dog. I'm going to use a little bit of hot glue to do that. All I need to do is just put a little dab of hot glue, like that. And place it in like this. There we go. There we go. Stands up just like that. Next, I'm going to take the two button cell battery holders, put a little bit of super glue on one battery holder, spray some activator on the other button cell battery holder, and now put them both together, so then that way they can stick together better. Hold it into place. There we go. Right here is where I want to place the vibrating DC motor. Take some hot glue, put a little bit right here, and then place the vibrating DC motor into place. Put a little bit of more hot glue to glue it into place better. Next, I'm going to solder tin the leads of the 3-volt button cell battery holders. And then solder tin the wires of the vibrating DC motor. Solder tin the push button lock switch. And now solder everything together. Take the negative of the vibrating DC motor, although polarity doesn't matter, and connect it to the cathode of the 3-volt button cell battery holder. Next, I'm going to put a drop of super glue onto the push button lock switch. Spray some activator on the 3-volt button cell battery holder, and then glue the switch to the 3-volt button cell battery holder. Next, I'm going to solder bridge one of the leads to the push button lock switch over to the anode of the 3-volt button cell battery holder, and then solder the positive wire of the vibrating DC motor to the other lead of the push button lock switch. Next, I'm going to go and poke a hole in the dog's eye. And now enlarge the hole. And now I can place the RGB LED into place. Goes in right where the dog's eye is. Perfect. Next, I'm going to take the 8-pin IC socket holder and I want to connect it to the RGB LED, and I want to connect it to the power supply. But first, what I need to do is cut off the unnecessary leads, and that is pin 1, 2, and 3. Those leads are not needed. Pin 4 is ground, pin 5, 6, and 7 connects to the RGB LED, and pin 8 connects to the anode of the battery source. And now I'm going to figure out the position of the circuit. I'm going to place the 8-pin IC socket holder right here, and what I need to do is bend the anode leads of the RGB LED. Bend the cathode in the opposite direction, and the anodes in this direction. And I want to connect the cathode directly to the negative of the battery, and I'll cut off the excess anodes. And I want to place the anodes over to pin 5, 6, and 7. Next, I'm going to repeat the same process with this push button lock switch and connect it to the 3-volt button cell battery holder. And repeat the same process. And I'll solder bridge one of the leads to the anode. And I'll put a little bit more super glue on the push button lock switch. On this side, just like this, spray some activator on the 8-pin IC socket holder, and I want to glue in the 8-pin IC socket holder into place. Place it right here next to the switch. Wait for the glue to cure. Next, I want to solder tin both sides of the bridge wire. And I'll solder the bridge wire over to pin 8, and as you can see, I have too much excess. Cut off the excess. And I'll solder bridge it to the second pin of the push button lock switch. And there, pin 8 is now connected to the push button lock switch. Next, I'm going to solder tin the anodes of the RGB LED. And I'll solder the RGB LED to pin 5, 6, and 7. Next, I'm going to take the cathode of the RGB LED and bridge it over to the negative or the cathode of the 3-volt button cell battery holder. Solder bridge it together, just like this. Cut off the excess, and there, the circuit is almost complete. Next, what I'm going to do is test it out. I'm going to take the 3-volt button cell battery, connect it to the vibrating DC motor portion, test it, and it works. Now take the 3-volt button cell battery, place it where the Attiny portion is, and then take the Attiny and put it into the IC socket holder. Put it into place. Next, I'm going to take a negative wire and solder it to pin 4, and then solder it to the negative of the 3-volt button cell battery holder. And there, the circuit is now complete. And I'll turn on the switch of the Attiny, and as you can see, the RGB LED works. Perfect, the circuit is now complete, and it works. Next, I'm going to go and take the entire circuit and put it into place. Take the RGB LED, put it through the dog's eye. Next, I'm going to take some hot glue and glue the entire circuit into place. There we go. And there, the project is almost complete. Now, let's go ahead and test it out. Turn on the Attiny portion, and it works. And now, test out the vibrating DC motor portion. And the dog keeps falling over. It kind of works, but it keeps falling over. This shows me that there's a balance issue. To fix the problem, I'm going to take this piece of cardboard and place it right here between the legs. Doing this should keep it more balanced. I'll prevent it from tipping over. So now what I'm going to do is take some hot glue and glue that piece of cardboard into place. And now let's go ahead and test it out. And as you can see, it still has the same problem. So there's a problem with that orientation. Next, what I need to do is take some more hot glue and place a generous amount on the back of the dog. Doing that should give some more weight towards the back, which should make it more balanced. Now, let's go ahead and test it out and see if that worked. And there, as you can see, it works. Perfect. And
there you have it. Now you know how to make your very own Amazon box cutout Jitter dog with using an Attiny85 microcontroller, and the code is down in the link in the description below. And there you have it. Thank you for watching SciTech Tech. I hope you learned something new, and don't forget to like and subscribe, and of course click on the bell icon to be notified for future SciTech Tech videos. Till the next tech, goodbye.